we're going to present two applications, IAM Manager and S3 Manager. We use the Kotlin programming language. Application has an associated IAM identity with the minimal set of permissions attached. Each application has an associated cognito user for login and authentication. Each application has user interfaces that essentially wrap a logical set of connected SDK commands. The associated IAM user for the application provides the credentials for the API call. Both applications use the same code to lock down and encrypt the credentials and any related sensitive social data. The goal of the application is to make API calls quick, easy and repeatable to group logical connected sets of calls in a common interface. The IAM Manager has two top-level tabs, one for user operations and another for JSON policy file. Under the top-level tab, we have subtabs for create user, group and role operations. Create users, groups and roles, then add users to groups and roles. Under the top-level policy tab, we have three tabs for policy operation. A policy editor where we can edit the policy JSON file and create policy JSON files from predefined policy templates or simply paste in a new template. We have a manage policy tab. We can deploy policies edited or created in the policy editor, and we can delete policies. Finally, we have a tab where we can attach or detach our deployed policies from users, groups or roles. Now we will just briefly demonstrate IAM Manager. So we log in with a paraphrase, cognito password, and a paraphrase for the in-memory key store, and we will log in. If we have no created user, we'll create a user now. So we create a user called test user. We can select our user so it becomes available for future operations. We can create IAM credentials for our selected user. These are encrypted credentials. Once we've created a user with their credentials, we can create groups and roles to attach the user to. So we can create a group. We have a set of connected group operations. We can create a role. We have a set of connected role operations. When we create a role, we need a pre-existing policy file. So here is a trust relationship policy file. Create a role friendly name, and then we can create a role. Then we will see the follow-on role operations once we've created our role. Select our role to allow this particular role to be available for follow-on operations, which will generally be adding permissions via policy files. So we go to our policy file editor. We have some templates. We can select a template and edit the template. In this instance, we need to add the appropriate role arm. Copy an arm from our selected user, and we go to our editor, and we're ready to save this template. So this will allow us to assume a role. So we will attach this to a user. So this is a managed policy. Now we can assume a role with this arm, and we can see our edit was successful. So now the next thing to do would be to go to our policy operations, select this policy file and deploy it to AWS. Relevant description, so that helps us differentiate our policies when we look at them remotely. Once we set that up, we can deploy our managed policy file. So it'll be available now to enable a user to assume the role defined by the role arm in the policy file. We go to our attach policy tab and attach the policy to the selected user. Once attached, we see the list of attached policies for our user and the follow-on options. One option will be now to add some permissions to the role. Select the appropriate template, which will be a managed permission file. Here, simple permissions to list buckets. Save it as a managed policy that we can attach to the role. This will allow our user, when it assumes a role, to have these basic S3 permissions. We navigate to our policy file operations, select our policy, set it up with a friendly name, deploy it so we can attach it to the role. Once deployed, now we have 2 deployed policies. Go to our Attach Policy tab, select our policy, and now we're going to attach this policy to a role. Description comes important to remind us, so we attach it to a role. So now we see we have 2 lists of attached policies, a list for roles, a list for policies. Similarly, we would have a list for groups if we attach to a group. Once we select a policy in the list, we can see the follow-on operations. Now we can quickly clean up everything that we've deployed. So we can use the detach role, detach user, detach the attached policies. We can't delete the user group or role until we've detached all the policies. Once we've deleted all our attached policies and our remote deployed policies, we could go through and delete the groups and roles. We are unable to delete the user because it has credentials. So basically you can't delete a group, a role or a user if it has any attached artifacts. If we want to delete the credentials, then we need to put in the actual access key for the credentials that we want to delete. So this is the IAM Manager. We log out. Using Kotlin and the DSL from Tornado FX, it was relatively easy to put together all the different tabs in IAM Manager, where each tab grouped together a logical, cohesive set of SDK operations. The next application, S3 Manager, is a much simpler application. It's a Spring Boot Kotlin application which wraps the S3 SDK. We log into S3 File Manager with a Cognito password and the paraphrase, which is an alias for the in-memory key store. The S3 API is much simpler than the IAM API, so it's a much simpler application which just allows us to create buckets, upload and download and delete objects from buckets. Also, we have some helpful validation. Here we try to create a bucket with an illegal character, so we get a very comprehensive validation message explaining to us exactly how we can create a legal bucket name. So now we go through and create a series of buckets we can then use to upload objects to, download objects, delete objects, and then delete buckets. So this is the basic S3 API. There are some other issues here. So there are some validation. We have MD5 hashes, which Amazon calls e-tags. We do validation in the background to check that everything is uploading and downloading correctly. We will just upload different types of files, zip files and text files, different types of files. We will upload to the bucket to show we have a multi-select operation for batch delete. Select 2 files to delete in a batch. We can download files once they're uploaded to a predefined location in the file system. So in our folder, S3 data, this is where our downloaded files turn up. So we can see that file was not corrupted in the download. We're just continuing now, deleting all the objects and buckets. And when we've deleted all the buckets, we've cleaned up all the operations we performed